What's up guys, Vylocity from Pitchfork Academy here, back with another Unreal Engine 5 tutorial, and in today's video, I'm going to share some tips and tricks that I use to optimize my scenes and my lighting to improve performance while still retaining a similar visual look to the default Unreal Engine 5 settings. But just before we get started, if you guys like what we do here and you want to connect with more like-minded people, access to our Discord server, Mizzo's Dizzo, is available for just $1.50 per month via Patreon. The Discord server is becoming a pretty cool place to be, with tons of very cool, very helpful, and very smart people, as well as an integrated AI chatbot to help you with all of your Unreal Engine 5 related questions. Your $1.50 actually goes towards that AI chatbot because it is a paid model and is indeed very clever, as well as helping support us in what we do here at Pitchfork Academy. Without further ado, let's get into the tutorial. Alright guys, here we are in a default version of Unreal Engine 5.6 in the third person template, just so we can kind of run around with the character and see how our game's performing. But of course you can use this in any version of the engine, any type of template you want, but this is mainly for Unreal Engine 5. And the first thing that we can do is sort of look at what's going on in our scene. So right off the bat, the scene looks pretty good. We have some nice volumetric clouds, we have nice lighting, we have this really nice global illumination where we get the bounce lighting from the green platform here onto the wall, which is a realistic effect where the light rays sort of bounce off of this green platform and the color is then transferred to whatever's around it within a certain radius. And it looks really, really nice. And we also have some nice ambient occlusion in the crevices of any sort of corner. So wherever two corners meet, you get the nice ambient occlusion. This is also a realistic effect. If you look around in your house or your room, you will also see sort of a darkening where any two corners meet, and it's sort of is darkest in the corner, and then it fades out to the just the regular lighting in the scene. So that's a nice feature as well. But all these things added up together, they're not cheap, and there's other alternatives to these same effects that we can look at adjusting. But before we get into that, let's look at how to see what our performance is in the first place. And to do that, we want to go down to the console command at the bottom and type in stat. And then you'll see right here, there's a ton of different stat things that you can look at. But we want stat FPS. So I'll type stat space FPS and click enter. And it'll just put this information on the top right. And right away, you can see our FPS, frames per second, or our frame rate, and our frame time below that. So we're at about a 13 millisecond frame time. And the frame time is essentially how long it takes your project to render one frame. And it directly relates to the frames per second. The lower your frame time, the higher your frames per second will be. And it's usually directly correlated. So if we were to half our frame time from, let's say, 13 to 6, our frame rate would essentially double as well, and we would get nearly 150 frames per second. And if you're anything like me, you love playing games that have a high frame rate, but also look good as well. So we're going to look at some different ways to kind of increase our frame rate and lower our frame time. So what we want to do first is to, first we're going to look at one more console command, and that is the stat GPU. Right away, this is going to look pretty confusing. There's a lot going on here, but essentially this is showing us in order what is costing us frame time in milliseconds. So as you can see here, the top few here are over a second, or sorry, over a millisecond. And the first thing is our rendered deferred lighting. This is something that you cannot change unless you go to forward shading, which this video is not about. If you're interested in forward shading, maybe I'll make a tutorial on that in the future. But this is our deferred lighting, and then our post-process volume is next up. As you can see, this is costing us 2 milliseconds, and we haven't even done anything to our post-process volume. It's just the default settings in UE5. And then the next is the volumetric cloud at almost a millisecond and a half. And then we have our temporal super resolution. This is the anti-aliasing method that's shipped with UE5, which is nice because it allows you to upscale your scene from a lower screen percentage, and it keeps things pretty sharp. But it's definitely not cheap, and there's other alternatives. So one thing that we can test is just to disable our volumetric clouds, and we'll see the direct impact in real time. So as of right now, we're costing about 1.5 milliseconds, even above that. So if I just disable the volumetric cloud, you can see it disappears from our stat GPU. And now we're at about 10 milliseconds and hovering around 90 FPS. So just that in itself is a pretty big boost. And volumetric clouds are nice, but they're not necessary. You can always use a static clouds or a skybox of clouds, maybe an HDRI or cube map, whatever you want to call it. There's tons of resources about that online, and that would kind of fake your clouds for you. And depending on your game, it would be more than enough. But volumetric clouds are nice because they're realistic, but depending on your project, you might not need them at all. But let's say that you wanted to keep them, but just improve the performance of them a little bit. Well, what you can do is go to your volumetric cloud, and then in the details panel, scroll down and you'll see tracing max distance mode. If I change this from distance from cloud layer entry point to point of view, right away I saw an increase in our FPS, maybe between 5 and 10 frames per second. And our clouds also look better in the distance. So let me just really quickly remove our stat GPU. So to do that, you can just go to your console command and click up on the arrow key, and it will just pull up all of your most recent frames, sorry, not frames per second, all of your most recent commands. So if I click enter on stat GPU, it'll sort of toggle it back off. Now we can see our scene much better. And we can see in the distance here is what we want to look at. So if I just switch back to from cloud layer entry point, you can see we get more clouds and they go all the way down into the horizon. And it actually goes below the horizon. And in my opinion, it looks a little bit too noisy and busy. And most likely you're going to have mountains or vistas, or buildings, what have you, anything in the background that's going to cover that up anyway. So in my opinion, it's best just to switch this to distance from point of view. And we'll get some performance back, as well as it looks a lot cleaner in the distance. You can also lower this tracing start max distance if you do want to keep it on entry point, and it'll bring it up above the horizon. So what I like to do is just lower this anyway, and then also switch it back to point of view, just to, maybe reduce some rendering that it has to do in the background. So now that we have that, we can look at some other settings in the post-process volume. And inside the post-process volume, we want to search for method. And right away, you can see we have global illumination and reflections. Maybe I can bring this up a little bit so we can see. You might have to check them on. I might have already had them checked on. So we have Lumen for global illumination and reflections, also Lumen. So Lumen is great, but there's some other options here. So if I just go back to this corner here where we can see the green reflection on the wall, or it's not really reflection, it's the global illumination. If I switch it from Lumen to Screen Space, you can see right away, we're now capped at 120 frames per second, and we're at 8.33 milliseconds. In my opinion, that is totally worth it. If you're going for more of a high performant stylized game, you really don't need Lumen in that case. Lumen is great if you're maybe making a story game or something that really needs to have great graphics or a really high-end project. It's awesome. But for most people, I do recommend using Screen Space Global Illumination. And you can also even use none. So I'm going to switch to none now. And we're getting about the same performance. And the reason that it's not going above this is because we're capped at the 120. So one way to uncap your project is to go to your console command and do t.max FPS and then click space and then just type in 999. Now we're going above our frame rate. So now we're getting, around 130 and our frame time is about 7. So if I go back to screen space, global illumination, you can see our frame time's now at 8 and we're getting less than 120 sometimes. And if I go back to none, we're getting pretty much always above 120 into 130, and our frame time's hovering between 7 and 8. So it just depends on what you're going for visually, and sometimes it hitches there. You can see it was going down to 50. But it really comes down to the visual quality. So if we switch back to screen space beta for the global illumination, you can see we do get that nice global illumination of the color on the wall. But it depends really if it's worth it to you. For the most performant project, I would recommend doing none. And then we have also Lumen reflections. So if I just click on our floor here and I find a clear coat material maybe, just so we can see some reflections. You can see we get these nice realistic reflections. But they are Lumen reflections. And the thing that is good about Lumen reflections is that they are supposed to stay on the screen no matter what. But for some reason in UE 5.6, it's defaulting back to screen space reflections. I'm really not sure what that's about. Um, but what we can do just to prove that is go to our method, and you can see we're on. Aha, that's what it was. So once you have lumen turned off, you can't use lumen reflections anyway. So as you can see now, if I have the object that is reflecting not on the screen, so this green pillar, you can see we still get the reflection because that is lumen reflections and it's not screen space bound. But as soon as I go back to screen space, global illumination, or none, and I have reflections on Lumen, you can see we don't see anything. And that's because it's defaulting back to screen space reflections. So I'll just select that anyway. And now you can see that we only get the reflection when it's on the screen. But for most cases, this is okay. And this is more than enough for an indie project, in my opinion. And it's much, much cheaper as well. So what we can do now is go back to our post-process volume, and we'll just double check what we've changed so far. So if I click this little settings icon here and click show only modified properties, we can see this is some exposure stuff that they set by default. So we've turned our global illumination off, and we've had reflection set to screen space. The next thing that we can do, since we have global illumination off, is get back some of that ambient occlusion. So if I search ambient and I just check back off modified properties, you can see we have this ambient occlusion stuff. So if I go to a shadowed area, like maybe over here, and I slide intensity down and back up, you can see it's a slight self-shadowing in the corners, as you can see right there. And in my opinion, if you are not using the ambient, or sorry, if you're not using global illumination with the bounce lighting for the colors and stuff on the wall, just having this ambient occlusion on here is nice, and you can increase it maybe to 0.75 or 1 if you really want the effect. And then the radius is going to control sort of how far from the wall or from the corner the effect comes out. I think the default value of 200 is nice, and it's going to give you some nice shadows in the corners. So I'll leave intensity at maybe 0.75, and we can move along. So the other thing that you'll notice after turning lumen off, we're not using any sort of screen space global illumination, and we're just using none. You can see that so now it's much brighter, but if I switch back to none, it gets pretty dark in the shadows. So a tip that I like to use is to go to your skylight and just increase the intensity to 2. And it sort of gives you back that nice ambient look of lumen or ambient occlusion without using that feature. So that's one way you can do it, is just play with your intensity scale. I probably wouldn't go above 3 or maybe 5. If you're going for really stylized games and your shadows are supposed to be soft, of course you can use any value that you want, maybe 10 or whatever. You can still see shadows just like you see here. But I recommend maybe a value between 2 and 5. So I'll just stick to 2. Again, here's 1, pretty dark. So there's an intensity of 2. The next thing that we can do is on our skylight, you can see the mobility is set to movable. And if we hover over mobility here, you can see a stationary skylight has its own shadowing baked into bent normal AO by light mass, but its lighting can be changed in game. Okay, we're not too worried about that. But if we change to stationary, it's going to take a sec to render, and we switch back and forth from movable to stationary, you'll notice that it also gets a little bit brighter. And that's because when you have movable skylight, it enables a feature called distance field ambient occlusion. I know we've thrown around that word quite a bit today, but there's different methods of ambient occlusion. For example, we have the Lumen ambient occlusion that we disabled, and then we enabled the default ambient occlusion in the post-process volume here with this. But in the skylight, if you have movable skylight, it enables distance field ambient occlusion, which again can give you some really nice self-shadowing in corners and things. But again, it's not cheap and it's not free. So setting it to stationary turns that feature off, and it still looks pretty good because we get the other ambient occlusion in the corners here from our post-process volume. So again, if I do this, you can see a little bit better now that I've turned the distance field ambient occlusion off by switching our skylight from movable to stationary. I don't recommend doing static unless you're going to do baked lighting, which baked lighting, as you can see here on the tooltip, is the fastest rendering, but it's not as efficient of a workflow. You have to basically constantly be baking your lighting as you're making your game. So I recommend stationary or movable if you want that distance field ambient occlusion, which in this default level, maybe it's not as obvious what it's doing. But if you're in a level with trees and stuff, you'll see that difference between movable and stationary. All right, so now we're hovering around 130-ish, 140-ish frames in about a 7 millisecond frame time, which is pretty good. But we also aren't full screen, so if I go full screen, of course, it's going to be a little bit more because now we're rendering more pixels. But a game will always render faster in a packaged build anyway, so this is a good gauge, but remember your frames per second should increase actually when you fully package your game because it's not running in the editor with stuff in the background. The next tip that I want to look at is going into our project settings. So I'll go to Edit and Project Settings. I'll just double click the top to full screen it, and we can scroll down to the rendering section. And we want to just scroll down even more. And here we have our global illumination and reflection. So this is actually where you can set it by default in your project instead of doing it in the post-process volume. So if I just click on Lumen here, I can set it to none. Or remember, if you want to use screen space, that's fine too. And then reflection method, it will default to screen space anyway if we have Lumen off, but I'll just set it to be screen space anyway. And then the next thing that we can try to mess around with is the shadow map method. So you can see here we have virtual shadow maps on, and this is a newer shadow method inside of Unreal Engine 5, which works good with Lumen and things like that. But if you're not using Lumen and you want to use the default old method of Unreal Engine, you can switch back to shadow maps. And we can read this here: render geometry into shadow maps for shadowing, requires manual setup for shadowing distances, and yeah, it can cause poor performance with high poly scenes. And that really is the difference between the two shadow map methods. So if you're using high poly scenes, you're probably going to use Nanite, and you want to stick to virtual shadow maps. But if you're going for more of a traditional rendering style with low poly meshes, using LODs, you'll want to probably switch to shadow maps. Typically, I like using shadow maps, but it really just depends on the project. I'll leave it on shadow maps for now, and we'll see any difference. So in this case, it looks like it's actually lowered our frames per second. That's interesting. I wonder if it's because this scene has a certain amount of high quality meshes. We can maybe check that out. Let's check this mesh here. Okay, so I see what's going on. So since we have nanite on all of these meshes, probably the shadow map method is expecting to use virtual shadow maps because this scene is using all nanite. If your scene is not using nanite at all, it's probably the best to use the regular shadow map method. But if you're using nanite, in this case, in this scene, it is using quite a bit of nanite. So I'll just enable this and we get our better performance back. The next thing that I want to look at is the anti-alias method. So the anti-aliasing is basically the sort of method that smooths out jagged lines when sharp straight lines are at an angle. So if I change my anti-aliasing method from temporal super resolution to none, you'll see that we now get these jagged edges on any straight edge that's diagonal. If you line up your scene perfectly so that the edge is fully straight with the camera, you won't see it, but of course that's not realistic. In a game, you're going to be moving your camera around and you'll see all these edges. So that's the point of anti-aliasing. So if I switch it from none to FXAA, it looks quite a bit better. For a super stylized project or maybe a mobile project, definitely FXAA is a good alternative to using none. But the TAA method is the other standard anti-aliasing method that was very popular before Unreal Engine 5. In Unreal Engine 5, they released the TSR, which is a little bit sharper, but it costs a lot more. TAA is great for getting some performance back, as well as making your scene look very smooth. So you won't really see any anti-aliasing jagged edges with TAA. The drawbacks, though, are going to be some sort of blurring in motion. So if you're making a very um, very fast-paced, high-action game where your characters are moving around all the time, maybe a shooter game, you might notice some blurring with TAA, or maybe in a car racing game, anything that has a lot of movement fast, you might notice a little bit of blurring with TAA. But if you're making any sort of like adventure game or something that's a little bit more cozy or chill, TAA is going to be pretty nice. As you can see here, now we're getting almost 160 frames per second and we're down to 6 milliseconds. And that's because in our stat GPU, we're not going to be rendering that temporal anti-aliasing anymore. And we see we have TAA at 0.15 milliseconds, and that's much lower than the temporal super resolution, which was at almost like 1.7 milliseconds or something like that. So let's take a look at what else we have here. So our volumetric cloud, we pretty much half to that. Our post-process volume, we half to that. Shadow depths, that's the same because we left on virtual shadow maps. This might change depending if you're, going to go with virtual shadow maps or shadow maps. And then the other thing that we haven't really looked at too much is the nanite stuff. So you can see here the nanite vis buffer is at 0.4 milliseconds and nanite base pass is at 0.25 milliseconds. Now, if you're starting from scratch and you know you're not going to be using nanite, you can actually fully disable nanite in the project settings, and that should remove these from the GPU. So if I search for nanite, you're going to see here a nanite checkbox. So it just says whether to enable nanite rendering. You can just simply uncheck this and restart your project. I'm not going to do it in this project because I'm going to stay in this default template level with everything is already nanite. But if you're starting from scratch or you already have a bunch of meshes that are not nanite, I recommend turning nanite off entirely. If you're going with the old school rendering style of using a little bit lower poly meshes, in that case, you don't really need nanite. So in that case, that would really reduce our frame time even more, and we'd probably be going up another 10 to 20 frames just from that. So definitely something to keep in mind about nanite. Another tip is to look at our screen percentage. So if I click this little speedometer icon up here for performance and scalability tools, at the bottom here, you can see that we have screen percentage. And by default, Unreal Engine 5 sets it to be based on sort of your computer specs to lower it below 100 to basically increase your performance because it by default uses the TSR or temporal super resolution anti-aliasing, which again we changed to TAA. So you can click custom override here and then set this to be 100, and your scene generally should look sharper now by that much. But this is just a temporary thing. If you go out of your project, open it back up, whoops, it will be back to how it was. So what you can do is go to your project settings again and search for screen percentage. And right here, you can see some stuff. So we have manual screen percentage set to 100. That's good. But it's saying here that screen percentage mode for desktop renderer is based on display resolution. We want this to be manual. And then also in the editor performance section, we have the similar option here. So we can change based on display resolution to manual. And then that should be good. If you're using mobile, of course, you can adjust that there. For non-real-time editor viewports, you can adjust that there. I'll just change it for the editor, and I'll make sure that these are both on 100. Now, if I go back and go to my screen percentage, I can uncheck custom override, and by default, it should be on 100. So that's really nice if you want the full visual fidelity of your scene, the sharpest scene possible, you'll want that. But one thing to keep in mind is even though we're not using TSR upscaling anti-aliasing method, the TAA method, if I go back to project settings, sorry, I know we're kind of bouncing all over the place here, but if I go back to anti-aliasing, or not anti-aliasing, if I just search temporal and go full screen, you can see here we have under, or not under, but above our anti-aliasing method, we have temporal upscaling. So whether to do primary screen percentage upscale with temporal AA pass or not. So this is enabled by default, most likely. And if I go back to the editor, and let's just really quickly remove our stat GPU. Just get to where we can see some lines here. If I go to screen percentage and lower it to really low, this would be extremely low. 32 is unheard of, really. But if I turn off now temporal upscaling, you can see now it's just super blurry. It's a little bit more stable though, but it's really, really blurry. And we're getting really high frames, of course, because we're really low screen percentage. But this is a nice feature. This means that you can keep temporal upscaling on, and as long as you set it to a reasonable value, so here's 100, but here's 80, and how much visual will change? If I go 60, then we start to get a little bit of flickering here on the edge, but it continues to stay decently sharp. I wouldn't recommend 60 unless you're a really low spec computer, but maybe 75 would be a good middle ground or base for using TAA and still getting some nice frame rate and the nice smooth edges. But again, if you're wanting the highest fidelity, you'll just keep this on 100. And then I assume you can just turn off temporal upscaling entirely. It doesn't look like it's changing the performance too much. Could be very minimal, but I just recommend leaving it on. And then maybe in your game, you can give the user a setting for basically adjusting their upscaling. So in a lot of games, for example, in the finals, the FPS game, they have a ton of different anti-aliasing methods. One of them is TAAU, which is essentially just TAA, but with this checked on. And then under that is a slider bar where you can essentially drag your screen percentage down. So I think 80 is a good middle ground there to keep your scene looking sharp, but perform it. All right, guys, that's going to do it for this video on project optimization and some overall lighting settings that I like to use to improve performance while still retaining that visual clarity inside of Unreal Engine 5. If any of these tips improved your performance, I'd love if you left a like on the video and subscribe to our channel. And if you have any tips of your own that maybe I left out, which I'm sure I did, I'd love to hear from you down below in the comments. This has been Vylocity with Pitchfork Academy, and I'll see you in the next one.